G'day, my name's Steve and this is Rewiring Workshops. Today we're going to look at fitting a 4QD controller to a battery electric locomotive. The first thing I need to do is work out how I'm going to wire all the components up. So I've made 3 drawings and it's all based around this terminal block, as that's the common point for everything. So the first drawing shows you the control box, the handheld control box, how it connects into the plug and socket. This goes onto the back of the locomotive, this plugs into that. So here's the wiring diagram for that. Got the pin connections there and a few other items such as the horn and the lights that need doing. There's our terminal block, as I mentioned. Then the second drawing shows the other side of the terminal block, all the bits that are hardwired into the locomotive itself, including how the 4QD controller is wired up. And then the last drawing is about the batteries and how they're interconnected to the rest of the locomotive. And then I've got the 4QD manual, and here's a nice little coloured diagram they do for showing you how to wire up the 4QD card. The first step in wiring up is to wire up the motors. So I've turned the chassis upside down, and here's a diagram supplied by 4QD on how to do the wiring for the motors using ferrite coils I should say, and some capacitors. And this is all designed to keep the electrical signal clean so it doesn't have any spikes in it and it doesn't damage the 4QD controller and its electronics. The first part of the wiring requires capacitors and ferrite cores to be added to the wiring of the electric motors. So what I've done is I've added separate terminal blocks for each of the motors to add the capacitors. Then I've interconnected the 3 motors into a bigger terminal block feeding off to the controller. You'll see there's another red capacitor there. All this wiring has been soldered on the ends to help protect it from corrosion and to stiffen everything up. And I've used the same length of wires for each motor to try and keep the circuit resistance the same for each one, and the larger cables are used to help with the current flow to help the motors pull whatever power they require. Here in Australia the weather's a lot hotter than it is in the UK, so I'm fitting a heatsink to the 4QD controller, and this is my setup. These are used materials off another job, but what I've done is I've used this stainless steel backing plate, which I've bolted the 2 heat sinks off, and then this is the mounting bracket for it here. So the 4QD goes on there like that. Here it is installed on the chassis of the loco. I've also mounted these 2 circuit breakers on their frame there. There's that terminal block you saw in the drawings. I've got a sound card over here, isolating switches and wires going to the motors, lights and horns. I've got this plastic box here which is going to be the handheld controller for the locomotive, and I don't want the drill to wander all over the place, So I've clamped it down with these milling clamps, marked it all out in pencil where I want everything is, and now I can drill through without the risk of the drill wandering off to one side and out of alignment and then making the whole thing look horrible. I've got two large holes that I want to drill in the end here. You can see I've made a start on them. As the plastic is fairly soft, I'm putting this wooden packing in here, and then I can clamp it up. This is the setup for drilling the holes. The holes is actually 1/2 inch or 12.7 millimeters in diameter, and I've gone up in stages. I've gone up in 1/32 or approximately 1 millimeter sizes, from about 1/4 inch or 6 mil size up to the 1/2 inch, and I've done that to ensure I don't crack the plastic, and that then gives me a nice hole for this to go into. So I'll clean this all up now and I can fit the grommets. You'll notice that I've got two outlets here for cabling, and the reason why I'm going to do that is because to do all the different functions with all the different switches, I would need at least 13 wires in a cable. Well, you can't actually buy a 13 wire cable with a big enough amperage. What's more common is this cable here, which only has 5 wires in it. Now, how a lot of the electric loco designers get around it is they put some circuitry in here called a multiplexer, and what that does is it looks at what all the different switches are doing, sends that down as a pulse of signals down the wires to the other end, to the loco, splits that up and then performs the function from whatever that switch was operating. So that means I only need one cable like this to do the job of those 13 wires. Well, I'm not experienced enough to know how to set up a circuit in here to do that. So I'm going the old-fashioned way of just switches and wires direct. So I've worked out the minimum number of wires I can put in here, which is 9. So if I use 2 of these 5 wire cables, gives me 10 wires altogether. So I've got my 9 plus spare. So I'm going to use 2 cables coming out of the control unit. So you may be asking, well, what's happened to the other 4 wires that you need? So what I've done is I've put 2 switches on the locomotive itself. One of them is going to be for the lights, the other one's going to be for the engine start. On the sound card here, both of those I don't really need on the remote. So I've made up these brackets to hold the switches. You can see they're all made of scrap material out of my scrap box, and that'll get around the 13 wire problem that I need. Also, these 2 plugs here for the 2 cables, one's an 8-pin plug, the other's a 5, and I've done that deliberately so that I can't interchange the plugs and wire things up incorrectly. When it comes to charging the battery between runs, what I've done is I've bought this smart charger off the internet. So what this does is it's plug in and forget, and it'll sense the charging of the battery, make sure it's fully charged up, then it switches itself off. Every now and then it'll do a test to see if the battery's needing a charge again, and it'll boost if required. So I can leave the whole thing alone, and I know when I want to run the locomotive next, the batteries will be fully charged. So what I've decided to do is I'm going to put this Anderson plug in place of these two here, and then down here and in a position where you won't see them is a connection for that, and then I'll hardwire that to the batteries. I've got one on either side because I'm going to keep the two batteries separate and charge them separately so that they don't interfere with any of the electronics or themselves. So then it'll be a case of plugging in and then forgetting and worrying about it next time you run. I've got all my bits and pieces ready to go to solder up the cable for the battery connections. I'm using big wire, and you may think, why am I doing that? Well, it's simply because I have this big roll of wire here. Why go buy other stuff when you've got this to use? The soldering iron I'm using here, you can see, is a homemade job. I made this during my apprenticeship when I was a teenager. So now what I'm going to do is I'm going to solder the wire. So I'll just gently let it heat up. Got some resin core solder that you can see here. Just put the roll in so you can see it there. Being very careful not to get any of the fumes where I can breathe it in. Takes a little bit to warm it up because it's quite a big wire size. There we go. Plenty of solder on there. Next I'm going to tin one of the Anderson plug connections. So I'll put plenty in there. Possibly an overkill, but we'll make sure it solders. And I'll grab one of the wires, heat that up again. Place it in. Pull it off and let it cool down. Similarly with the lug that's going to go onto the battery, I'll tin that and then heat the wire up and place the wire in it. Again, make sure you're in a well ventilated area so you don't get overcome by any of the fumes that are coming off it. And then we just wait for it to cool. There we go. You can see I've got a little bit of exposed wire there. So to tidy things up, what I'm going to do is I've cut some short lengths of heat shrink with the scissors. Just going to pop them on here. And then shrink them down with the gun. tightens it up quite a lot. Then I'll just clean all this residue off and we're good to go. So I've got everything wired up now, and as you can see, the batteries are being charged up. It all looks a bit of a mess at the moment, but I've got a few more wires to put on, and once I've put them on I can tidy everything up with cable ties, etc. I've now added the 3 extra switches that are needed that I couldn't put in the control box. So the first one is to operate the lights. The second one is an engine start. So I've got a sound card on the loco and it has a startup sequence, and then it runs controlled by the controller and varies its speed. So that's the startup procedure. And then this one down here will be for an amp meter, voltmeter, that I don't really need, but nice to have, so I can check how the batteries are doing. More about this in part 2. I've also put this terminal block on here, and you can see I've started wiring up the low voltage side. This is the 12 volt side, so I now actually have the headlights working. So if I turn on the 12 volt circuit breaker, I can now measure between my negative and positive. I've got 12.7 volts, 12.8 volts, keeping the wires separate so you don't get any intermix there. And then when I flick that black switch, I can go to the terminal block for the lights and I can see 12 volts coming through there. When I come to wire things up, I have 2 criteria. These are commercial fittings that you buy with insulation on them, and then the idea is you crimp them, put your wire in and crimp, but I find 2 faults develop here. First of all, this can corrode, creating a high resistance joint, and sometimes when you crimp down on these, they don't always crimp down on the cable, particularly if it's designed to be used with a bigger cable than what's required. So what I do is I take this insulation off, and then I just fill this section with solder. I then tin this with solder, heat it all back up again, put it all in, allow the solder to settle by taking the soldering iron off, obviously, and then I will follow up with this heat shrink which I put on. Possibly don't need that, but the more you can insulate things the better, so that's how I choose to do it. Here's an example of what I'm talking about. So I decided to terminate one of these on that red wire, so I get a more positive lock on that circuit breaker. So I've stripped the little blue insulator off, soldered the red wire in place, and then covered it with the heat shrink. The other end goes in the terminal block. Once again, same thing. This has been tinned. I don't leave the copper bare, and then it just crimps down, and you can see that's locked on solid. It's not going to go anywhere. It's not going to corrode or cause me any other issues. I've just spent last night working on fitting up more of the different elements of the engine. So here's the common for the horns. I've got 2 horns on the engine. It's the British style where you go dee doo dee. So this is the positive that's going to the 3-position switch. Sorry, this one's the positive, and either side of that are the 2 horns, and this is the negative return. So they've all been tinned and put into the terminals. Other thing I've done, you can just see there, The second switch has been wired up now, and that's the sound card. This is the sound card here, and that provides the trigger to start the system off. It also needed 12 volts. You can see the red and black there, so I've fitted up the 12 volts. Another one here for positive and another one here for the negative. So what are the tools of trade do I use for wiring up? First of all, I have a large soldering iron here. You can see in both cases here I've cleaned the tips periodically. Because they're made of copper, you need to give them a good clean as they oxidize. Get the tips nice and clean. Now next time I heat them up, I will tin this section here before I start soldering. I've done the same thing with this one. This one needed reshaping slightly as well. This one's getting to the point where really I need to put a brand new tip on it. So the large one is used for things like this, where I need to hold it against here to heat the whole body up, and then I can fill it with solder. Then I can tin the wire and then place the wire in, heat the whole thing up and melt it all and release it, let it cool, and that makes that joint. I was talking about removing the insulation before, so here's one that's insulated. This one's the same item with the insulation removed. The small soldering iron, of course, is used for the smaller cable, but you also need it for things like this. So this little switch has a lot of plastic involved with it, so, and very small tags, so you need a small iron to very carefully tin that, place the small wire on, and it has to be a fairly quick action, otherwise you could melt the body of the switch and damage it. Electrical solder, so this is resin core solder, so it has resin in the center of it. That I think is 2mm diameter, so there is thinner stuff, but I like using this stuff. I back it up with baker's fluid. I even touch baker's fluid on the tips here to keep these clean while soldering. And I've got a nice dispenser here and brush that I can use for keeping parts clean. Then everything's washed in water afterwards and given a good clean up. This brings us to an end of rewiring the battery loco. Pleased with the way it's progressing. Hopefully I've been able to give you a few good hints and tips. So we'll carry on adding extra features in part 2. See you then.